Hello, I'm Neil with the Forcetronics YouTube channel, and welcome to Reducing Arduino's Power Consumption Part 3. And in Part 3, we're going to look at one method to further increase our power savings when we're using sleep mode, and then we're going to look at how to use the Watchdog Timer to wake up the Arduino from sleep mode. Let's get started. Okay, one way to further increase our power savings in sleep mode is to turn off the ADC. In Part 2, we used the ability to turn off the ADC to increase our power savings when we were using the power reduction registers, or PRRs. So we can do something similar when we're in sleep mode. If we turn off the ADC, we can increase our power savings. If you look at the screen on the bottom left, I'm using a power supply with highly accurate measurements, and you've seen this reading before, but this is basically the reading you get when the Pro Mini is in power down sleep mode. And then if we turn off the ADC, we can see we get further savings. So here it shows the wattage getting cut in half, but really it's a little less than half. The instrument's rounding up in the wattage, and you can see the current. In the first two bullets, I show a way to turn off the ADC. In Part 2, I showed a simplified way by just setting the ADC SRA register to 0. Here I'm showing a more elegant way to do it, and I'm just showing how to do it using that exact bit inside that register. So the register has 8 bits. I'm just going to turn off or mess with the 1 bit. Instead of my method in Part 2, I just turned off all the bits. So I'll have this in the example we'll see later so you can copy it from the code. Now let's talk about the Watchdog Timer. So what is the Watchdog Timer? The Watchdog Timer is a module that has a real low power clock, and you can basically set the module as basically a stopwatch, and when that stopwatch goes off, you can do certain things. Well, in particular, there's 2 things you can do. You can use the Watchdog Timer as a stopwatch to do a system reset. So people use this in real critical applications where if the chip were to get hung up, the Watchdog Timer would then go off and reset the chip. The second way you can use the Watchdog Timer as an interrupt source. So you can set the Watchdog Timer for so many milliseconds or so many seconds, and when it goes off, it signals an interrupt. And if you remember, we can come out of sleep mode using an interrupt. I mentioned the prescaler bits. The prescalers are basically what we define in the register for the stopwatch time interval. Okay, let's talk about how to set up the Watchdog Timer. Now, the Watchdog Timer does have a library, but unfortunately, the library doesn't allow you to set the Watchdog Timer as an interrupt. So in our code, we're going to use the library a little bit, but we also have to manipulate the register to set up the Watchdog Timer. So what you're looking at is actually the Watchdog Timer register, and you can almost think of this as switches on a wall, light switches on a wall. There's 8 of them, and a 1 or a 0 is going to turn on or off that light switch. So let's talk about the bits we need to adjust for the Watchdog Timer. First, what we have to do is we have to set or switch bit 4 and bit 3 to a 1. And this basically tells the Watchdog Timer, we're going to set you up, and we're also going to set your prescale. So we set these to 1, and then immediately after, we have to set up the rest of the Watchdog Timer. So we're going to set up then bit 6, and this puts the Watchdog Timer in interrupt mode. And then we use bits 0, 1, 2, and 5 to set up the time interval for our Watchdog Timer. So how long do we want our stopwatch to go before it triggers an interrupt? So here's how we're going to do it in the code, and once again, you'll see this in the example. Okay, next, let's go over the code for our example using the Watchdog Timer to wake up the Arduino from sleep mode. Okay, here we are at our code, and in this example, I'm going to blink the LED, and I'm going to use delays to blink the LED at 1 second intervals. But for one of my delays, instead of using the standard delay function, I'm basically going to put the Arduino to sleep and use the Watchdog Timer with a 1 second interval to wake it up. So first, I'm just going to call my sleep library. I'm also going to call my Watchdog Timer library. Now remember, I mentioned we're going to use parts of the Watchdog Timer library, and then we're also going to have to manipulate some of the registers. These here are actually defined variables for setting the Watchdog Timer interval, which I'll come back to in a bit. First, what I'm going to do is I'm just going to set up an LED pin, and then I'm going to set up a toggle bit. Next, in my setup code, I'm going to first disable the Watchdog Timer. Now, this is a function from the library, and basically the manual recommends that you do this. So in case something happens with a Watchdog Timer, you don't get in this infinite loop where the Watchdog Timer is constantly resetting the chip. I'm then going to set my pin to output for my LED. I come into this code, and basically this if and else statement are going to toggle back and forth as we go through the loop, and that's what that toggle variable is for. And here I'm just doing the standard, putting the LED high, delaying, putting it low, delaying. Then in the else statement, I do something very similar. I put it to high, I then do the standard delay, I then put it to low, but instead of doing the standard delay, use a sleep delay so I can save power. So let's look at this function, the delay Watchdog Timer. And you can see I'm actually, one of my arguments here is the defined variables, and I'm using the Watchdog Timer at 1 second. And you can see some of the different time intervals that they have. Okay, so here's my function, delay Watchdog Timer. And you can see my input or my argument is a byte. So first I'm going to enable sleep mode. I'm then going to define sleep mode. So here I'm going to use the deepest sleep mode, which is the power down sleep mode. I'm then, as I mentioned, going to turn my ADC off. So right now I'm just setting up sleep mode. I turn my ADC off by ANDing it with the particular bit. Doing it this way is nice because you're only affecting one bit, the bit you're interested in, and the other bits remain at the same state they were at. Here's then when I set up the Watchdog Timer, and we saw this in the slides. I need to set these two bits, and then I need to enable the bit 6 because this is going to turn it to interrupt mode. Then what I do is I OR these bits with the timer argument or the timer variable. And so I'm going to take in this 1 second variable, which is a byte, and then OR it, so it's going to set up my prescalers how I want them to be set up, and basically set my register for the prescalers and to set up the Watchdog Timer in interrupt mode. I'm then going to reset my Watchdog Timer, so that's just going to start the timer from 0 position. Then I'm going to put my Arduino to sleep. So that's where it stops executing code. The Arduino goes to sleep. The only thing is somewhere in the chip you have the Watchdog Timer running and counting down. So once it reaches 1 second, it's going to signal an interrupt. This special function, you can see I have this special argument in here, is what's going to be called next. You should have this interrupt service routine here or things are not going to work right. Here inside the interrupt service routine or the ISR, I'm going to disable the Watchdog Timer. Okay, so that's our code, and basically remember what's going to happen. We're going to see our LED blink, but during one of the low periods, we're going to see the power jump real low. So let me show you that. Okay, let's look at the benefits of sleep mode and the Watchdog Timer. So this is what I've done is using my power supply instrument, my advanced power supply instrument that I'm lucky to have access to at work. I basically captured the current of my Pro Mini running the code that I just showed you. So what we're looking at is actually the current, and we have the value of the current on the y-axis and time on the x-axis. So let me explain what's happening. When we see these pulses, this is the 1 second interval when the LED is on. So if you remember, the LED turns on and we delay, we then turn it off and we delay for 1 second, we then turn it on and we delay, and then here's where the sleep mode comes in. We use the Watchdog Timer for this delay, and you can see the current jumps way down. In fact, I did a measurement to sort of compare them. So when we're not doing anything and we just do a standard delay, we're still using 3.72 milliamps. But when we do a Watchdog Timer delay where we essentially put the chip to sleep, you can see we're only consuming 40 microamps, and I don't think that's correct. I think the measurement accuracy, since I'm taking fast samples, is not quite right. But the point is it's very low current. How would we use this? If you don't need the chip and you need to put it to sleep for a defined amount of time, you can use the Watchdog Timer. You would use an interrupt pin when you want it to go to sleep for some amount of time that you don't know, some asynchronous amount of time, and something external is going to wake it up. Okay, before we wrap up, let's look at some other ways to save power that were not covered so far in this series. One way is to slow down the CPU clock rate. If you're not using the chip for tight timing applications, you can actually slow the clock down. And by slowing the clock down, you're using less power over time. I mean, it's simple math. I'm not going to get into that. That's fairly advanced. It's in the data sheet if you want to try it, but that is another way to save power. The other way that I have not covered is turning off the brownout detector. Now, the brownout detector is a function that detects your input voltage, and I think I have a bullet for that. And what happens is if your power source dips or something happens to it, it will detect it and reset the chip. Let's say you're real concerned about power and you're pretty confident that your source is going to be reliable. You want to turn off the brownout detector because it'll give you further power savings even in sleep mode. The problem is I've tried, and you basically can't turn it off in software in the Arduino IDE. At least I haven't been able to, and I think it's because there's certain things that need to happen in a certain amount of clock cycles, and I think because of the different layers in the Arduino IDE, it does not work. Now, there is other ways to turn it off using the AVR programmer, which you would have to buy and use some of the software that Atmel makes. I think there's a way to do it by adjusting some files. I want to keep doing some research into this and find the easiest way and maybe get back to you on this in a part 4. So those are 2 other methods to lower the power consumption that were not covered. So here I want to conclude. I do want to mention that someone asked me this. On my Pro Mini board that I've been using for these examples, there's a power on LED. Not the LED that's connected to pin 13, but there's a power on LED. I essentially broke that LED so it wouldn't be using power. So if you're doing this at home and you're seeing higher power usage, it's probably because your LED is still on. And on my Mini, I broke the LED. Okay, if you're interested in the code that we covered in part 3, go to my blog. You can copy it from there. Of course, the access the data sheet. If you found this useful, please subscribe to my YouTube channel. If you have any questions, you can email me. Thank you for watching.